Hello students, myself Sarama Malik Das, Assistant Professor of Gargi Memorial Institute of Technology. So today I discuss about the matrix representation of a graph. So here we shall consider the two ways of representation of a graph and the diagram. First one is incidence matrix. Of a connected graph. Okay, so first I discuss how can you find the matrix from the graph. Okay, let G be a graph with n vertices and e edges. Suppose G contains no self loop. So we define a matrix A is equals to capital A is equals to Aij n cross E. That means vertex is in the row and edge is in the column. Okay. So whose rows corresponds vertices and columns correspond to edges. As Aij is equals to 1 if jth edge Ej incident on the ith vertex, that is Vi, and this is equals to 0 otherwise. Okay, this matrix, this is called incidence matrix. Of G. Okay, and is written as A of G. Okay, so we find the incidence matrix. So this is the combination of edge and vertex and edge. Okay, vertex is in the row position and edge is in the column position. Okay, so we draw here. First example. First we draw the graph. See, this is our graph. Okay, so this is V1, V2, V3, V4, V5, V6 and V7. This is edge E1, E2, E3, E4, E5, E6, E7 and E8. Okay, this is the graph G. Now we can find the matrix. Here the number of vertices is 7 and the number of edge is 8. So the incident matrix, height of the incident matrix is 7 cross 8. Okay, that means A of G is equals to Aij. This is of 7 cross 8 here. Okay. That means this is equals to, you can define here. So first we write the columns. Okay, E1, E2, E3, E4, E5, E6, E7 and E8. And the vertices V1, V2, V3, V4, V5, V6 and V7. Okay. So first we take the edge E1. E1 is connected with the two vertex V1 and V2. Okay, that means E1 is incident to the vertex V1 and V2. As we write here that jth edge Ej is incident on the vertex ith vertex, that is Vi, then Aij is equals to 1. Okay, that means E1 vertex is incident to the vertex, E1 edge is incident to the vertex V1 and V2. So this position is, two position is 1 and others positions are 0. Okay, clear? Now take E2. E2 is connected with V2 and V3. So only V2 and V3 position is 1, others position are 0. Take E3. E3 is connected with V3 and V6. V3 and V6 position is 1 and others position are 0. E4. E4 is connected with V3 and V4. So only V3 and V4 is 1, others are 0. E5. E5 is in between V2 and V4. So V2 and V4 is 1, other are 0. E6 in between V4 and V5. So V4 and V5 is 1, others 0. E7 and E8 both are in between V6 and V7. Okay. So these two position is 1 and here also for E8 V6 and V7 is 1. So this is our incidence matrix. Okay. So you can find easily from the graph, the matrix from the graph. Okay. Now we find the graph from the matrix. Okay. I can find here. Okay. So our graph is, first I say here the matrix. Our matrix is this. This is our matrix. Okay. So see here. Here this matrix contains 5 rows and 6 columns. Okay. So number of vertices is 5 and number of edges is 6. Clear? So we just write here the vertices, say V1, V2, V3, V4, V5 and the edges are E1, E2, E3, E4, E5 and E6. Okay. So we first plot the vertex. Okay. Say this is V1, V2, V3, V4, V5. V1, V2, V3, V4, V5. Okay. Then first column contains 2 placed. First column, that is E1, consists of 2, 1. That means E1 is connected with V2 and V3. Just connected V2 and V3 and write it E1. Okay. Then for E2, E2 is connected with V1 and V4. So E2 is connected with V1 to V4. This is E2. Next E3. In E3 column V2 and V4 is 1. So E3 is connected with V2 and V4. This is E3. Then E4 is V4 and V5. This is E4. Next E5. E5 is V1, V4. V1, V4. Oh, that means this is the parallel edge. E5. Okay. Then E6. E6 is in between V1 and V3. V1 and V3. This is E6. So this is our graph. Okay. Now we can find the incidence matrix of a connected digraph. Okay, so how can we find the incidence matrix from a digraph? Let G be a digraph with n vertices and e edges. Okay, suppose G contains no self loop. Okay, so we define here A is equals to matrix capital A is equals to Aij n cross E. This is also same. Here also vertex corresponds to the vertex corresponds to the rows and edge corresponds to the column. Okay, and here Aij is equals to 1 if jth edge is incident out of ith vertex. Okay, jth is incident out of the ith vertex, then it is 1, and it's equals to -1 if jth edge is incident into ith vertex. That means when the vertex, when the edge is out from the vertex, that is equals to 1, and into the vertex, that is equals to -1. Okay, and is equals to 0 if jth edge is neither incident out nor incident into ith vertex. Okay, so this is the main formula, and this is called the incidence matrix of digraph. It is also denoted by AG. Okay, so for example, I draw here the graph. Four vertices there. Okay, this is E1, this is the this is E2, say it is E3, and it is E4, this is E5, this is E6, this is E7, and this is E8. Okay, so here E1 is incident into V1 and incident out V2. Okay, E8 is incident into V1 and out V4. Okay, and again E2 is incident into V1, out V3. Okay, so the matrix is defined as, we can define the matrix this way. Here the number of edge is 8. Okay, so E1, E2, E3, E4, E5, E6, E7, E8. V1, V2, V3, V4. So it is 4 cross 8 matrix. Okay. Now edge E1 is connected between V1 and V2, but it incident into V1, incident out V2. That means V1 is -1 and V2 is +1. Others are 0. See here, E1 is connected between V1 and V2, but it is incident into V1, that means direction towards V1, that is -1, and direction outwards V2, that is +1. Okay. Similarly for E2, here the direction towards V2, that means V2 is -1, and outwards V3, that means V3 is +1. Okay. Next for E3, E3 is between V3 and V4, but the direction towards V3. Okay, so V3 is -1, V4 is +1. Similarly for E4 is connected between V1 and V4, but its direction towards V4. That means V4 position is -1. Okay. For E5 is connected between V1 and V3 and direction towards V1. So V1 position is -1. E6 between V2 and V4 and direction towards V4. V2 and V4 direction towards V4. That means this position is -1. And for E7 is between V3 and V4 and direction towards V4, so it is -1. And E8 between V1 and V4, direction towards V1. Okay, so this is our incidence matrix from the diagram. Okay, now we can define the we can find the diagram from the matrix. Okay, we can write here the matrix 0 0 1 -1 1 -1 1 0 0 0 0 0 0 0 0 1 0 0 0 -1 0 1 0 0 0 0 0 -1 1 0. Okay, this is our matrix, and here number of row is 6 and number of column is 5. Okay, so the matrix is 6 by 5 matrix. That means number of vertex is 6 here and number of edge is 5. So we can write here V1, V2, V3, V4, V5, V6, E1, E2, E3, E4, E5. Okay, so we can draw the diagram here. V1, V2, V3, V4, V5, V6. V1, V2, V3, V4, V5, V6. Okay, So E1 is in between V2 and V4. So we connect V2 and V4, and V2 is -1, that means direction towards V2. This is E1. Okay, E2 is in between V2 and V5. V2 and V5. There is no -1, so there is no direction. Okay, this is only E2. And E3 is in between V1 and V6. So this is E3 and direction towards V6. E3, because V6 position is -1. E4 is also same between V1 and V6, and here V1 position is -1, that means direction towards V1, and this is E4, so it's the parallel edge. Now E5 is in between V1 and V4, this one, and here V4 is -1, that means direction towards V4. This is E5. Okay, but here V3 is not connected here, that means V3 is a V3 is disconnected here. Okay, so V3 becomes isolated here. In fact, G is not connected here. Okay, this graph is not connected. So this is our graph from the incidence matrix digraph. Sorry. Okay, so there are some properties also. I can define here the properties. Number 1, an incidence matrix of a graph non-digraph. Okay, contains only two elements, 0 and 1. Because of this incident matrix of a graph is a binary matrix. Okay, so this is the this is a binary matrix. But digraph is not a binary matrix because there is the three elements, 1, +1, -1 and 0. Okay. Now, if the graph is not digraph, then each column of an incidence matrix contains exactly two ones, since every edge is incident to exactly two vertices. Okay, that means each column consists of two ones. Okay, but in the digraph each column contains 1 + 1 and 1 - 1. Okay, that means if in your problems each column contains more than two ones, then it will be wrong. Okay, So next properties is, for a graph, the number of ones in ith row is equals to degree of Vi. But for a digraph, number of ones in ith row is equals to positive degree of Vi, and number of minus 1 in jth row is equals to negative degree of Vj. Okay. So property number 4 is, if Vi is an isolated vertex, then all the elements in ith row are 0, and it's also true for the vice versa. And if there are r number of parallel edge connecting Vi and Vj, then r number of columns in the matrix are identical. Okay. So in a diagram, the two lines joining same pair of vertices are not treated as parallel. Because there are the direction is in the opposite direction also. If they have the opposite direction, then they are not parallel. But if they are in the same direction, then they are parallel. Okay. And the last property is, if in the incidence matrix of a digraph, all minus r1 are changed to plus 1, then it converted to a undirected graph. Okay. Now you can you can find also the incidence matrix of the disconnected graph. Incidence matrix of a disconnected graph or digraph. Okay. Let G be a disconnected graph or digraph having two components, G1 and G2. Then the matrix will be in block diagonal form. As AG is equals to A of G1 0 0, A of Z2. Okay, where AG1 and AG2 are incidence matrix of G1 and G2. Okay, and O is the null matrix. So we can find here, see, say this one. Here it is V1, V2, V3, V4 and V5, V6, V7. This is E1, this is E2, E3, E4, this is E5 and this is E6. Okay, so this is the total graph G, and this consists G1 and G2, two components. So the incidence matrix is incidence matrix of the component G1 is, for first we find for G1, G1 is V1, V2, V3, V4, E1, E2, E3, E4. Okay. E1 is connected between V1 and V2. E2 is connected with V2 and V3. E3 is connected between V1 and V3, and E4 is connected between V3 and V4. Okay, so it is AG1. And for AG2, this is V5, V6 and V7, E5 and E6. E5 is in between V5 and V6, and E6 is between V6 and V7. So this is our matrix. Okay, so the matrix G, that means A of G, this is equals to A of G1 O, A of G2. Okay, this, that means this is equals to V1, V2, V3, V4, V5, V6, V7, E1, E2, E3, E4, E5, E6. E3, E4, then E5, E6. Okay, this is our incidence matrix for the disconnected graph. Okay, you can find the graph of from the incidence matrix also. Okay, so in our next lecture we discuss about the next ways of representation of matrix, that means adjacency matrix.